Hello, Matrix. My name is Retief, and I'm a project manager with the South African Institute of Chartered Accountants. Normally at this time of year, we'd be seeing you at your schools, or you'd be with us at one of our Tutuga development camps. But because of the situation, we aren't able to do that currently. If you're feeling a bit frustrated and annoyed, we completely understand, because we're feeling the exact same way. And we understand how tough it must be without having the extra support to help you through. And whilst we can't be with you in person, we're trying our best to be with you in the only way we can right now, and that's digitally. To help you with your matric revision, the team and I have reached out to some of our favorite educators to create a series of videos in the most common problematic topics that matrics struggle with. We hope that these videos are able to assist you and help you feel less alone during this time. All the best for your matric exams, and good luck, matric class of 2021.
Welcome back. So we're going to look at this question over here. So my apologies for having the answers in there already. I did the question, or I did the video, and then my laptop went error. So I'm going to have to redo this question. Alright, anyway, so we got a parabola and we got a straight line, and it's got a turning point at -1 and 18. Alright, so the first question is, calculate the x-intercept of S. So if we look at the graph there, it's cutting the x-axis at S. So therefore, at the x-intercept, the y value will be 0. So bring that over, it becomes 2x equals 4, so therefore x equals 2. So S has got the coordinates of 2 and 0. Alright, 522. Determine the equation of k in the form at y equals a x plus p squared plus q. So this is referred to as the turning point formula. Now if you look at the turning point, the graph is moving 1 left and 18 up. So that means for the graph to move 1 left, P's got to be positive 1 and Q's got to be 18. So a point on the graph, which is 2 and 0, that's what we worked out over there. So the y value is 0, x is 2, take the 18 over, it's minus 18, 2 plus 1 is 3, 3 squared is 9, 18 minus 18 divided by 9, so therefore a equals minus 2. So y equals minus 2 bracket x plus 1 squared plus 18. Next question, 523 is calculate the coordinates of t. Now if we look at t is the point of intersection between the straight line and the parabola, right? So for the point of intersection is make the two graphs equal to one another. So minus 2x plus 4 equals minus 2x squared plus minus 4x plus 16. Right, it is quadratic, so bring everything to the left, so that becomes 2x squared minus 2x plus 4x is 2x, 4 minus 16 is minus 12. Divide by 2 because there's a common factor of 2. So that will give me x squared plus x minus 6 equals 0. That's x and x. That's 3 and 2. So that's going to be a plus and that's going to be a minus. So x equals minus 3 or x is equal to 2. So this answer is not applicable because that will give me the coordinates of S. I'm not interested in that. I'm interested in the coordinates of t. So t would be minus 3. And then substitute minus 3 into the straight line or into the parabola. I prefer the straight line. Minus 2 times minus 3, which is 6, plus 4, which gives me 10. Right, so 524. It's asking where k of x, which is the parabola, is less than the straight line. So that means where is the parabola below the straight line? So as you can see, the parabola is below the straight line over here. Then it's above, and then they are equal, and then they are below. So there are two answers there. So where x is smaller than minus 3, or where x is greater than 2. If it's further given that g, the derivative, is equal to k, which is minus 2x squared minus 4x plus 16. So for which values of x would g be concave up? So the graph changes concavity when the second derivative is greater than 0. So that would be minus 4x minus 4. So minus 4x minus 4 is bigger than 0. Bigger than 4. So therefore x must be smaller than minus 1. So remember, when you divide by a negative, the inequality sign will change. Okay, now sketch the graph of g, clearly showing the x values of the turning point as well as the points of inflection. Alright, okay, so let's just quickly draw axes there. Right, so we know that the derivative is equal to minus 2x squared minus 4x plus 16. So at the turning point, the derivative is equal to 0. Divide by negative 2. So that would be x squared plus 2x minus 8. Let's factorize that. So the factors are 4 and 2. So it's a plus there and a minus there. So x equals minus 4 or x equals 2. So those are the turning points. Minus 4 and 2. And we know that the point of inflection is at minus 1. So if the derivative is negative, therefore the cubic function must be negative. So that means it's got to be decreasing. So if it be decreasing, it's got to go down, up, down. So here we go. Down, up, down. So that's the point of inflection. Okay, the 2 over there is a bit off. Let me just fix that. That's a bit better. Sorry about that. So that x value there is 2. Alright. So that is the equation. That's what the g would look like. Now there are lots of other ways that you could have sketched g, as long as it turns at minus 4 and it's got a point of inflection at minus 1 and it turns at 2 and it's a decreasing function. Alright, let's turn over to the next question, which looks like that. Okay, now there's quite a lot going on in the information. Okay, so I'm going to try and just single out what is required. Alright, so it says show that the equation of gx is equal to x plus 1. Now that is the equation of a straight line. So the equation of a straight line is y equals mx plus c. So what I look for is, I try to look for where the y-intercept is. Now we can see that the y-intercept is 1. So therefore the c value is 1. So that would be mx plus 1. So then a point on the graph, and that is c. So c is the only point on this graph, on the straight line. So the y value is 5 and the x value is 4. So 5 minus 1, which is 4, so that would be 4m. So therefore m is equal to 1. So the final answer is x plus 1. And that's proved what they asked us to do. Alright, 6.2, calculate the coordinates of A and B. Alright, now if you look at A and B, those are the x-intercepts of the parabola. Now in order to work out the x-intercepts of the parabola, we make y equal to 0. So 0 equals x squared minus 2x minus 3. So it's a normal trinomial. Let's factorize that. The factors of 3 is 3 and 1. A minus and a plus, so x equals 3 or x equals minus 1. So what you got to do is you got to look at which side is A and which side is B. So A is negative and B is positive. So the coordinates of A and B are minus 1 and 0 and 3 and 0 respectively. Right, 6.3, is to find the range of f. Now, in order to find the range of f, you need the turning point. So you can either use minus b over 2a, or you can find the derivative. I prefer the derivative. So the derivative of f, which is 2x minus 2. So at the turning point, the derivative is equal to 0. So 2 equals 2x, therefore x is equal to 1. Right. So substitute 1 into the original equation, so that will become 1 squared minus 2 times 1 minus 3, which will give me minus 4. So therefore the turning point would be 1 and minus 4. So the range is from minus 4, so you can see there's my turning point. The range is from minus 4 to infinity, so this way, up. Alright, so minus 4 is the lowest point, so therefore the range is y is greater than or equal to minus 4. Right. 641. Okay, sorry about that. There we go. Right, 641. Okay, so it's determine the length of OT if t lies on the negative x-axis. Show all working. So the length of mn is 6. Now, so basically, it's the parabola minus the straight line must equal a length of 6 units. So that y value minus that y value must give me an answer of 6 units. Alright, so distribute in minus 2x minus 3 minus x minus 1 minus 6 equals 0. So that's x squared minus 3x minus 4, it's 10. Right, let's factorize that. So that's the factors that I would use there is 5 and 2. So x equals 5 or x equals minus 2. So we are not interested in this answer because it said if t lies on the negative x-axis, which is this one, right? So the length of OT, remember the length can never be negative, so therefore the length is got to be 2 units. Hence, write down the coordinates of n. So as you can see here, that x value is minus 2. So that means this x value is minus 2, that x value is minus 2, and that x value is minus 2. So therefore the coordinates of n is minus 2 and y. And the equation of the straight line is y equals, I think it was x plus 1. There we go. So it's y equals minus 2 plus 1, so therefore y equals minus 1. So therefore the coordinates of n are minus 2 and minus 1. 6.5. Determine the equation of the tangent to f drawn parallel to g. So if we look at g, which is x plus 1, so the gradient of g is 1. The gradient is 1. Alright. Now, parallel lines have equal gradients. So f of x is equal to x squared minus 2x minus 3. So the gradient to f is the derivative, which is 2x minus 2. So equal parallel lines have equal gradients. So this gradient should equal the other gradient. So that will give me 3. So x equals 3 over 2. So the x coordinate at the point of contact is 3 over 2. So substitute f of 3 over 2, because that's on the graph of f, a tangent, it's a point of contact between a straight line and the parabola in this example. So you got 3 over 2 squared minus 2 times 3 over 2 minus 3. Okay, so let's work that out. 3 over 2 squared minus 2 times 3 over 2 minus 3, and that gives me minus 15 over 4. So the point of contact is 3 over 2 and minus 15 over 4. So the equation then would be y equals x plus c, and the point of contact is 3 over 2 and minus 15 over 4. So the y value becomes minus 15 over 4. The x value is 3 over 2 plus c. So minus 15 over 4 minus 3 over 2, I think that's minus 21 over 4. There we go, minus 21 over 4. So therefore the equation then becomes y equals x minus 21 over 4. Alright, there we go. Last question that. The last question there is 6. For which values of k will the graph of x squared minus 2x minus 3 and the h of x, x plus k, not intersect? Okay. Now, if you look at h of x, which was x minus 21 over 4, so that's the answer found in the previous example. Alright. Now, if you look at the parabola and where they meet, so the point of contact was, let me just get it right quickly, 3 over 2 and minus 15 over 4. So that is where they are meeting currently. Now this equation is x minus 21 over 4. So clearly you can see that the gradients are the same. So they are talking about this graph here. Now obviously if you take that graph and if you move it up, see now they're intersecting twice, right? Now if you take this graph and you move it down, can you see they don't touch each other at all? So that means we got to move this line, we got to move it down, then they won't intersect. So therefore the k value must be less than 21 over 4. Then they won't intersect. Alright, there we go. Those are the 2 examples in this video that we're going to cover. Stay tuned for some more. So we've got 2 more questions on the parabola and the straight line. And then we're going to move over to the exponentials and the log graphs. Alright, stay tuned for more.